Hey guys, I'm back with a new video. So in this video we'll learn about operators that we can make use of in Python. So we have 7 types of operators and we'll go over all of them in this video. So the first is arithmetic operators, then assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. So first is arithmetic operators. So what are arithmetic operators? Arithmetic operators are those operators that are used with numerical values to perform some common mathematical arithmetic operations. So operators in Python. So first we are going over arithmetic operators, and I will define a variable, say number a, and set that to 3, and number underscore b, set that to 2. So now I will print number underscore a plus number underscore b, then print number underscore a minus number underscore b, and let us copy this and paste multiple times and just change the operator here. Then I will say multiplication, division, modulus, exponentiation, double asterisk, and the floor division. So number underscore a, double slash, and number underscore b. So this is floor division, and let us run the file, and you can see for addition case we are getting 5. When we subtract the two numbers we got 1. On multiplying you are getting 6, 3 into 2. On division you are getting 3 by 2, which is 1.5. So that is, we are getting the result as a float. If you want to convert the float into int, you can wrap this like this and use the int function. And if we run the file for 1.5, now you will get 1. Let us see this, and you can see now we are getting 1. Okay, and back to our original output. If we take the modulus 3 on dividing by 2, we get the remainder of 1. So we're getting a remainder of 1. And then exponentiation 3 raised to the power of 2, which is 9. And then floor division, so 3 by 2 gives us 1.5. And then we are saying that we want to round it down, so we want the floor value of that, so which is 1. So now let us move forward to assignment operators. Now these operators are used to assign values to variables. So let us leave a comment here, assignment operators. So first is our normal assignment statement like this. If I say number underscore c and set that to 4, so number underscore c is a variable that will contain the value 4, and if we print that, we will get 4 to the terminal. Now what if I want to increment the value of number underscore c by 3? I can use 2 ways of doing that. I can say number underscore c, whatever current value you have, add that to 3, and then you will get a new value of 7. So let us print that to the terminal and run the file. So you can see here we are getting 4, and when we increment 4 by 3, we are getting 7. And the alternative syntax for this can be this. So if I comment this out and say number underscore c plus equal 3, and if we run the file now, we'll get exact same output, 7. Now without wasting any more time, let us see more on assignment operators now. So number underscore c minus equal to 3, and I will print number underscore c, then number underscore c into is equal to 8, and print number underscore c, then number underscore c divide equal. So now you know how we can evaluate this. This is equivalent to number underscore c equal to number underscore c divided by 3, just like this. So let me leave one more comment here, number underscore c divided by 3, and then we can print number underscore c, and then we can do same for the modulus operator, the exponentiation operator. I leave that as an exercise for you. So if we run the file now, we'll get the output for these. So now let us understand about the comparison operators, and this you will mostly find being used in conditional checks, which we will discuss later. So I will say comparison operators, make some space here, and I will say 3 double equal to 2, and then I will print. So this is the equal to comparison. 3 not equal to 2, so not equal to comparison. Print 3 greater than 2, greater than. Print 5 less than 3, less than. And these conditional checks first get evaluated and basically spit out a boolean which is either true or false based on the check that we are using here. Then I will say print 4 greater equal to 4, and this is greater than or equal to. Then print 4 greater than 4, print 3 less than equal 4, and I'll leave a comment here, less than or equal to, and print 3 less than equal 3. So let us run the file and see the output for this. So here are the results. For the first one we are getting false, for the second one we are getting true because 3 is not equal to 2. For the third one we are getting true, for the fourth one we are getting false. Now for the fifth one, which is 4 greater than equal 4, it's indeed true, so we are getting true. 4 greater than 4, which is false. 3 less than equal to 4, true. 3 less than equal 3, true. So now let us move forward to logical operators in Python. Logical operators. So what are logical operators? Now these are those operators that are used to combine conditional statements. So you have been using comparison operators. Now what if we want to combine two conditions and each condition is using a comparison operator? So I can say print 3 less than 2, which is one condition, and 3 greater than 1, which is other condition, and then print 2 less than 3 or 5 less than 3. So what is the difference between and or keywords? Now and wants that both the conditions should be evaluated to true. So if this condition and this condition is true, then the result for this will be true. What happens in OR is that if either of the conditions is true, the entire result will be true. So in this case, only this condition will be true and this is false. So the entire result will be true because we have at least one condition that is satisfied. And here, since 3 is less than 2 is false and this is true, so false and true will be false because we have one condition that is failing. And then what we can do is we can use the not operator, and within which we can pass a condition. So 2 less than 3 and 5 greater than 2. So now let us run the file, and here also we will get boolean results back. So for the first one we are getting false, for the second one we are getting true, and I've already discussed that. So let us see why we are getting false for this condition. Now 2 less than 3 is true and 5 greater than 2 is also true. So true and true will be true, and if you take not of true, so not of true is false, and that is why you are getting false. So now moving forward, we have identity operators. Identity operators are used to compare the references, whether they point to the same object, that is they share the same memory location, or they are different objects. So this we will understand when we will discuss about objects, or you can say dictionaries, in great depth in coming videos. So for now, let us see an example for this. So I will say print 1, 2, 3 is 1, 2, 3, and print 1, 2, 3 is not. So you can see we are using two operators here, is and not. So is not 1, 2. So now let us run the file, and you can see we are getting false and true. So 1, 2, 3 is represented as an object in memory, and this is a different object in memory, though it has the same data as this one. Now since both these objects are different and they are residing at different memory locations, they are not equivalent, and that is why you are getting false. And 1, 2, 3, which is an object sitting in the memory, and this object is another object that is sitting at some other memory location, they are not identical, which is conveyed by the condition. So this is not this, which is true, so we are getting true as the output. So for the first condition, which is this one, it returns true if both of the things being compared are the same objects, which is not the case here because they are residing at different memory locations. And for the second condition, this returns true if both the variables are not the same objects, and they indeed are not the same objects. That is why you are getting true. So now let us discuss about the membership operators. A membership operator is used to check whether a thing is present in an object or not. So I'll leave a comment here, membership operator. So I will say print 1 in. So to check membership, you can use the in keyword, 1 in 1, 2, 3, and print 7 not in. So we can use these two operators, 7 not in 1, 2, 3, and 7. So now let us run the file to see the output. So for this one we are getting true because 1 is a part of this list, so it is true. 7 not in this, it's false because 7 is a part of this list, and that is why we are getting false because we are doing a negative check. Because here we are claiming that 7 is not a part of this, which is false because you can see 7 is present at the last index of this list. So finally, let us go over the bitwise operators. So bitwise operators are used to compare binary numbers. So bitwise operators, and they are important. So we have bitwise and, bitwise and, bitwise or, bitwise XOR, so OR and XOR. XOR is denoted using this symbol. Then we have bitwise not, which is denoted using this symbol, not. And then we have the left shift operator, left shift operator, and the right shift operator. So now let us first discuss about the bitwise AND operator. So I will define two numbers, number underscore 1, and set that to 8, and number underscore 2, set that to 5. So for understanding this, you should remember what 8 is in binary. 8 in binary looks like this, so 100. So 8 in binary is represented as 1000, and 5 is represented as 0101. So if we want to compute bitwise AND for these two numbers, we can say print number underscore 1 and number underscore 2. Let us run the file now, and we are getting 0. So let us see how we are getting 0. If I take the binary representation of both these numbers and perform bitwise AND, so from the AND operator you can realize that if either of the bits of both the numbers, that is if the corresponding bits of both the numbers are different, you are going to get 0. If they are 1, then you will get 1. If they are 0, you will also get 0 in that case as well. So let us perform bitwise AND bit by bit for the binary representation of these numbers. So if I say 0 and 1, you get 0. 0 and 0, you get 0. 0 and 1, you get 0. 1 and 0, which is a bitwise AND, you get 0. So you get 0, 0, 0 in binary. And this is equivalent to 0 in decimal, and that is why you are getting 0 in the terminal. So now let us perform bitwise OR operator on our given numbers. So I will say print number 1, and I can use this symbol, number 1, number 2. Let us run the file, and now we are getting 13. So let us evaluate how we are getting 13. So just focus on the rightmost bits of the binary numbers. So 0 or 1, it will give you a 1. So I will say 1 at the rightmost end. Then 0 or 0 will give you a 0. And then 0 or 1 will give you a 1. And 1 bitwise 0 will give you 1. And if you convert this to decimal, you will get 13. So now comes the bitwise XOR operator. In case of this, if corresponding bit or both the numbers are same, then it is 0, else it is 1. So let us apply this rule to understand what we get for both the numbers. So I will say print number 1 XOR number 2. Okay, so focus on the rightmost end of these two binary numbers, 0 and 1. So 0 and 1, these two bits are different, so you will get a 1 at the rightmost end of the result. 0 bitwise XOR with 0, so this will, because both the bits are same, you will get 0, and 0 XOR with 1, you will get 1 because the bits corresponding to these positions are different. 1 and 0 again 1 because the bits are different, and 1101 is again equivalent to 13 in decimal. So this is the result. So if we run the file, we should get 13, and you can see we are getting 13. Now then we have Bitwise Not. So this will return the ones complement of the number. So I can say print and use the tilde operator. So number 1. So I am applying the Bitwise Not on number underscore 1. Let us run the file, and you are getting -9. This is very easy to guess. So how this works is that the number 1 in binary is 1000. Number 1 is 8, as you know, and it is represented as 1000 in binary. So when you apply the ones complement, you can say like this, 1000 plus 1, and this will give you minus of 1001. And if you convert this to decimal, you will get 9. So it is -9. And from the output you can see the result is -9. Now coming to the final operator set, that is a part of the Bitwise operators, and that is the shift operators that I want to cover. Now these operators are used to shift the bits of a number left or right, thereby multiplying or dividing the number by 2 respectively. Now they can be used when we want to multiply or divide a number by 2. Now let us first understand about bitwise right shift. So let me change this to right and left. So the right shift operator, what it does is that it shifts the bits of the number to the right and fills the vacant spaces that we get as a result with 0. It is equivalent to dividing the number with some power of 2. So let us consider an example to understand this. So I will define a variable g and set that to 10, and 10 in binary is 1010. And if I say I want to shift 10 by 1 position to the right and print that, so what should we get as the output? Let me wrap this in a print statement. Now when you apply the right shift operator on this right shift, okay, what will happen is that this one will move to the right by 1 spot, this 0 will move to the right by 1 spot, this 1 will move to the right by 1 spot, and lastly the 0 that we are having will get dropped. So the very first one will get replaced with a 0, and this one will now go to the next spot. So 0, 1, then we come to this 0, it will go here, and finally this one will take the place of this 0, and the last 0 will get dropped. So 0, 1, 0, 1, and this is 5. So now if we print the result, we should get 5, and you can see we are getting 5 by applying the right shift operator. So now let us see the left shift operator. Now the left shift operator shifts the bits of the number to the left and fills the vacant spaces that we get as a result with 0. So it is equivalent to multiplying the number with some power of 2. Now here you can see we are dividing the number by 2. We had 10 when we performed right shift, by 1 bit, we got 5. With left shift, if we apply the left shift on 10, we should get 20 because this multiplies the number by 2 or some power of 2 depending on the number of shifts that you are performing. So I will say G and I will use the left shift operator. It is pointing to the left and 1. So this says left shift by 1 position. Run the file and you get 20. And let us see how we get that. Each bit will shift to left by 1 spot. Consider 8 bit and perform the left shift on this. What will happen is each bit will shift to 1 position to the left and you will get 0 0 0 1 0 1 0 0, and this is equivalent to 20 in decimals. So this is how the shift operators work in practice. So this was all about the video on operators. So if you liked the video, do give it a thumbs up, subscribe to the channel, hit the bell icon for all the upcoming uploads, and I will see you guys in the next video.